In this video, we're going to take a look at the common ways that process methods are executed. And there are 4 common ways that they're executed: delayed, continuous, or repeated, immediate, and definition. So we're going to take a look at each of those. And again, these are the most common ways that process methods are executed. In a successive video, we'll cover some of the more uncommon and advanced ways that they get executed. So the first thing we're going to take a look at is delayed. And for this video, we're going to be using one of the tutorial scenarios, and we're going to be looking at the source code for some of the tutorial models. I have Forge open here, and I'm going to open up the example scenario called tutorial single shooter. And when it asks me if I want to log in as the example user, I'm going to say no, which is what we should always do so that we don't overwrite the example data sets. And here's my blue shooter. You can see he's got a locate, a start, a log output, and an assess. So I'm going to execute this scenario. You have seen this scenario before, but I want to look at some of the execution output that comes out. So here we are in the output for this scenario. So I'm just going to go ahead and reset. You see that assess is initiated, and you don't see log output in the output because it's log output that enabled the logging. So logging was enabled when this log output command was initiated. But then here's assess. And you can see that assess message here says assess initiated. Now, and as you know from previous scenarios, it's this log output command right here that is causing the output to show up for this user. And one of the things it does is it logs all activity with process method, with command initiation and process method execution. So it's really handy for this particular tutorial because we get a chance to see what's really happening with the cognition models attached to this unit. So assess is initiated, and then sometime later, assess is executed. So you can see that the execution of the assess process method, which is this one right here, is actually delayed. It's sometime after the time that it was initiated. This is intended to simulate is the amount of time that it would take a unit to actually perform this particular command. So you can see it's a little over 3 seconds later that it actually got executed. So that's why we call this delayed execution. And this is probably the most common way that process methods are executed. A command gets initiated either from the definition of the unit through its task, its set of commands, or internally, which happens more often, internally initiated commands. And then some point in the future, when we are simulating that the unit would be able to complete that command, then the command is executed. So it's executed at the completion of the command. The same thing happens with engage. So engage is initiated, and it gets initiated by assess, and then sometime later, the engage actually executes. So the timing on these commands is kind of silly, but you would set them when you're developing cognition models to be times that are representative of how much time it would take a human to actually perform that command. So first of all, let's go look at how it is that first of all, let's take a look at the source code for the assess command. So I'm going to pull up Visual Studio, and I'm opening up my solution. And here is the EXM cognition model. Actually, we're not using EXM cognition. This is a shooter command, the assess. And by the way, if you're ever wondering what class it is that this belongs to, you can just hit the add command right here and go look at the command. So let me close this. I got to get below here to executable commands. And there's assess, and it will tell me the full name of the command if I don't already know it. And it shows me it's FEX shooter. And that's what gets printed out right here, so we know which class it belongs to. So here's FEX shooter, here's assess. This is the FEX shooter assess command. And there's nothing in here that specifies anything about how or when this particular process method is going to be executed. So I just wanted to show you that. It's not specified here. Where it gets, at least not at the beginning, where it gets specified is in the prototype for this process method. So here's the Flames model prototype editor. You can start that from the launcher. I'm going to open up the prototype file, which is this file right here, the MPP file. I'm going to navigate to that. So here's build, here's tutorial, here's F-Cognition, there's a shooter, there's the model prototype file, and here's the assess method. So it's the prototype that defines how this guy is going to be executed. In fact, all 4 of the ways that process methods get executed are defined in the prototype. So the most common default way that process methods execute are if none of these boxes are checked. So these boxes specify alternate ways of doing it. By default, it's delayed execution. So when we have none of these boxes checked, we're in delayed execution, so it doesn't execute immediately. And when it's checked, we have these timing parameters that are available. So underneath the execution tab, we see execution timing. So this specifies the amount of delay between the time the command is executed and the time the command is initiated and the time the process method is actually executed. So what this means is 5 plus or minus 2 seconds. So it's somewhere between 3 and 7 seconds. Every time a command gets initiated, Flames will do a uniform random draw between the earliest and the latest time to come up with a time somewhere between the bounds that you specify. So somewhere between 3 and 7 seconds. And then it will execute the command, the process method, that much time after the time it was initiated. So that's delayed execution. And again, you see that very common. It's very common. Let's look at Engage. Engage has a real short amount of delay. It's 2 plus or minus 1 second. So it's between 1 and 3 seconds. If we go back to our scenario and we look at the time there, we can see that assess was executed about a little over 3 seconds after. So that's within the range. And then Engage was initiated, you can see here at this time, so it's at about 1.3 seconds after. Again, Flames does a uniform random draw, so it's all going to be random. If you don't want randomness in the delay, all you do is go in and change the delay delta to 0. By the way, this auto enable is a box that should almost always be checked. What this means is that when the cognition model is employed by the unit, this particular command immediately automatically is enabled. And by being enabled, it shows up in the, it's available to be initiated. Now this is an internal command, it's not visible. And we'll come back to that, but in another video on command visibility. The assess command is visible, so that's why it shows up over here when we do the command. So you see Engage is not in here, but assess is in here. So again, we'll talk more about that in another video. So that's delayed execution, pretty straightforward. So now let's talk about the other type of execution, and that's continuous repeated. Now this is actually specified in the source code. So we're going to go to the source code for assess, and assess does actually execute repeated. In fact, we're going to first look at the execution output. So after the engage is, I didn't actually let it run long enough. So let me run this a little bit longer. So I'll reset. So the way this thing works, if it finds a target, it initiates engage. So you can see there, it found one unit detected. It's engaging the red truck. So then engage gets initiated, and you see assess is not running. So this cognition model is set up to be able to engage only one unit at a time. So while we're involved in that engagement, assess is not running. When evaluate damage is initiated, we find out that we've destroyed the target, in evaluate damage, we initiate engage. So we start looking for targets again. When there are no units detected, so we don't even see anything else. In this particular scenario, there's only one red target, so we don't see any targets. So we reinitiate assess. And you can see that continues on here as long as the scenario runs. So this is now running continuously or repeatedly. And the logic for that is inside the code itself. So we're going to go look at the code, and we talked briefly about this in the specification for cognition models, but now I'll get a chance to see it in more detail. So we're back to the source code for assess, and we can see down here that when we found a target, so it's down here at the bottom, we're returning single. And what single means is execute only once, this whole process method only once. But if we don't return single, we don't engage, then what we do is we return continuous. And this is what causes the process method to be re-executed. Basically, the assess command gets reinitiated, which ultimately results in the process method being executed again. So this is to simulate a human who's just routinely doing the same thing. And you can have multiple process methods in continuous loops simultaneously. There's no limit to that. So you can have your human looking out the window, looking at his gas gauge, looking for targets, texting his mother, all doing all those things simultaneously. And how frequently actually really does it, how much time it takes for him to repeat that process is determined again by the process method prototype. So that's these times right here. Now in this case, we have the time set exactly the same, but when a process method is re-executed because it returns continuous, the time at which it will be delayed is actually the repeat time. And so if you went and looked at the execution output, you could see that all the times that it is delayed when it's reinitiated are somewhere between the same range of 3 to 7 seconds. So again, continuous repeated is very similar to delay, except that you don't specify it's delayed or continuous in the prototype. You specify that in the code, in the source code, by how you return, either single or continuous. So it makes it really easiest to simulate a human just doing something over and over and over again until you tell it to stop. And it's not burning up a lot of CPU because it's not actually running every simulation time step. This is all event-based, and so no CPU time is being consumed while we're waiting for the process method to actually execute. So we've covered delayed and continuous. Now we're going to talk about immediate execution. So in order to cause something to be immediate execution, you do specify that in the process method prototype. So before I actually look at the prototype, let's make a small change to our scenario to show something that is immediate execution. So I'm going to go back here to our scenario. So here's our scenario. We're going to take this blue shooter and we want to make a change to him, but because I can't make a change, I don't own that data set, I'm going to create an empty data set and I'm going to hit accept. And that will create my own copy of the blue shooter. And I'm not going to save this because I'm just doing this for this tutorial. And I'm going to add a couple of commands here. So first thing I'm going to do is add a move to waypoint command. And I'm going to put myself in command editing mode so I can see the waypoint here. And I'm going to put it right here. And I got to set the speed. It's a required input, so I'll make it say 30 miles an hour. And then after I initiate, I want this unit to keep going, so I'm going to add another move to waypoint command. And I'll move that command down. And then I'll just move this waypoint up here a little bit. And the reason I do that is if I've done some movement, then as soon as the last movement takes place, the unit automatically becomes inactive. So if I put a move to waypoint in the assess, the next there wouldn't be any more commands, and the unit would immediately go inactive. So the assess would actually never execute. So I've got to put some kind of command after this to let the guy stay active so that assess really happens. And we'll talk about what movement is. This is actually what we're talking about here in this particular video right now. So I'm going to run the scenario. So the unit's moving like that. You see the move to waypoint command, and it's executing immediately. So that's what we're talking about right now, is immediate execution. So when it gets to that waypoint, the assess command is going to initiate. And right after that, the next move to waypoint command is initiated. And so that's enough. So I can go here and look. The assess command gets initiated. And then we do the next move to waypoint command. Then it gets executed. And it's executing, looks like about a little bit more than 4 seconds after. And we do the normal engagement, evaluate damage, and then we initiate assess. And then it goes into its loop, just looking for more targets. So what is it that caused that move to waypoint command to be executed immediately? Well, it's in the process method prototype. Now, this particular command, if we go back and look at the log, that's actually the move to waypoint command is an FEX driver move to waypoint command. So I'm going to start another instance of the model prototype editor, and I'm going to open up the FEX drivers model prototype file. So here's the move to waypoint command, and you can see it's actually specifying execute immediately. So that's what causes this particular process method to execute right away. And we also normally check pause processing. And there's several different reasons why you could check pause processing, but the main reason, and the most common reason, is because this particular command is a movement command. And actually that's specifically what Flames considers when if there is a movement command in here. Technically what it means is if there's any command in here that paused processing. Flames just assumes that's a movement command. In this particular command, we don't want the command to execute or be considered to be completed based on a certain amount of time, the time that the unit would take to complete the command. It's not time that determines when this command is completed. It's movement that determines when this command is completed. So we're going to tell Flames pause processing, and it's going to be something else that's going to cause this particular command to continue. Command processing to continue. So what causes it to continue is when the movement that's commanded here is actually complete. Well, Flames doesn't know that by itself. It doesn't know what the platform model is really doing, but it's the platform model that tells Flames when, because this ultimately results in a command to the platform model. Platform model tells Flames, okay, I've just finished its command. The last command that I'm given. So let's go take a look at the code and see how that happens. So first of all, we're going to look at the move to waypoint command. So that's an FEX driver. Here's move to waypoint. And as you may not know this yet, but normally movement commands, what they end up doing is calling equipment control for the platform. So they're building up a mal, and they're calling the platform and telling the platform, this is what I want you to do. So the platform is then going to continue to do the command that it's been given until it completes. So how do we know that it's completed? So we're going to go to the platform, and I happen to know that the platform that's hanging off of this particular unit is a go down here to platform. It's this ground vehicle. It's the only tutorial model that we have. Here's the code for move. And I'm going to go through this real fast. You can look at it. So here's the move method. It's being called every single time step. we're in the move off road, so I'm going to go into move off road. And move off road calls move next step. And down inside of there, it's actually checking to see if it's reached the waypoint. When it does, it returns a move RC, which is this particular move type right here. If move RC is move complete, we stop moving, but we return that move RC back to the routine that called this, which is this guy right here. We take that return code and we return it ultimately from this guy. So when complete is returned, that's what tells the unit. So it's one of these guys right here. This is an enumerated value, and there's a couple of different values. One of them is success. So normally this guy's going to return success if it finished. If it returns complete, which again we saw in the other place, that return code is complete, that automatically tells Flames that the platform model has finished its most recently provided command. So what Flames will do then is Flames will go and it will resume command processing for the particular unit. So it will go to the next command. Now this one does not have pause processing set, so it'll initiate that one, and then because it doesn't have pause processing set, it will immediately execute the next command. And we can see that here. When assess is initiated, see it's being initiated at 51.5 seconds. So move to waypoint is initiated immediately after that because they're at the same time. But this move to waypoint also has pause processing, so we don't advance and other stuff starts happening. So that's a typical immediate execution. We use immediate execution for movement-related commands. And again, when we specify immediate execute immediately, we are almost always specifying pause processing. So why are we saying execute immediately? Why aren't we just saying pause processing and not execute immediately? Well, the reason is when the platform model returns continuous down here, Flames is going to go back to do command processing, as we've just talked about. If move to waypoint was a delayed, it wasn't executed immediately, then it would be sometime later that the actual move to waypoint command would be executed. And the execute would not happen before the next time step for the platform. So the platform would, in its next time step, which might be 1/10 of a second, might be a millisecond, might be a second, whatever you happen to have it set for your scenario, it would be called, the move method would get called again, and it would not have a command. So it just finished the previous command in its last time step. I get the next command, and I get the next time step, and there's no command. So we don't want that to happen. We want to make sure that a new command has been given to that platform before the next time step. So that's why we choose to execute immediately. So movement-related commands that are not considered to be complete until movement has happened. It's not based on time, it's based on movement. We will check both of those. And when that's true and it's executed immediately, its timing doesn't make any sense, so the execution timing values will be disabled. So that's immediate execution. And again, we are almost always doing that when we're doing movement to execute a command that's giving movement. There's other times where we want to do immediate and we don't specify pause processing because it's not a movement related command, but for some reason we want immediate to be checked. And it turns out that definition commands, that's a special kind of command, which we're going to talk about now, that those also happen to be executed immediately, but for a different reason. So we finished talking about immediate execution for movement-related commands, and again, those are very common also. Now definition commands, and this is the fourth very common way that process methods get executed. We have an example of a definition command in the scenario that we've been looking at. Definition commands are commands that are allowed to be initiated above the start statement. So when I click on this, put my mouse above the start statement and I click plus, only commands that are set up as definition commands show up in this list. So you can see we've got quite a few of them. There's 7 commands here that can be initiated above the start statement. So these are all definition commands. And when I go on or below the start statement, I hit plus, I now have several more commands that can only be, these are executable commands that can only be executed during scenario execution. As you may remember from composing units and other user training, the commands above the start statement are executed during the configuration of this unit. So scenario hasn't started, there is no time advancing, so it wouldn't make any sense for these guys to have a delayed execution because time is not advancing. There is no time at this point. This is being done during the configuration of the unit. So what is it that we do to say we want to allow the command to be executed in the definition section, executed during the configuration of the unit? Well, that's going to be in the process method prototype. So all this is handled in the prototype. So I go to the locate command, which is the one that we're looking at right here, and you can see that definition is checked. When I check definition, I can't check pause processing. It doesn't make any sense to pause processing because time is not advancing. So we're going to execute all the definition statements that are above the start statement. And it doesn't make any sense to specify timing because, again, as I said, time's not advancing. So automatically pause processing is unchecked and it's ghosted, and execute immediately is checked and it can't be changed, and the execution timing values are ghosted. So this is what causes it to be allowed to execute above the start statement. So let me tell you a little bit about special things when you decide to write a process method that's going to be executed, that can be executed above the start statement. This is super powerful. What this means is that not only can cognition models be used to allow the unit to simulate human behavior and decision processes during the execution of the scenario, cognition models and process methods can be used to help define the unit ahead of time. In this case, we're using it to specify the unit's initial position. So again, units can't do anything by themselves. So this allows us to execute our models, the models attached to the unit, in this case, a cognition model, during the configuration of the unit. So let's go look at the source code for locate. So I'm going to pull up Visual Studio again. We're going to go to our platform model, and we're going to look at the source code for locate, which is, it's a cognition model. That's over here. So here's our driver, and here is locate. And what he's doing is he's ultimately building up a command to give to the platform. So we're actually executing the platform model. So the cognition model is giving a command to the platform model. The platform model is what's responsible for moving the unit, so it moves the unit. So as a part, we're actually, this allows us to execute any model that we want, to make that model do anything we want to do during the configuration of the scenario. So you can do all kinds of things in here. One of the examples, you can go look at the airport scenario. It's got a really cool version. It's got a command called park. So you can go look at that. That's one of the starter process models. It's for the fixed wing aircraft. It has a park command, and park actually initiates a command for the air traffic controller, which figures out the next parking space that's available for the unit, and then initiates another command back to the fixed wing aircraft, giving it the position and orientation where it's supposed to park. We then give the command to the platform model to put the unit in the parking place. So it's pretty sophisticated stuff, and it allows us to just tell a unit park and ask this particular air traffic controller where to park. So we're using it to do a fairly sophisticated scenario creation, scenario editing, specifying initial conditions for a unit, and that let the cognition model do that for us automatically. And you can see, if you remember back in this particular guide, we've got quite a few definition commands. We can assign a zone, we can assign its commander, we can locate in formation, we can turn on log output, we can tell it to use a certain formation. Any kind of additional input and states and modes that we want to specify, It's the all-powerful cognition model that lets us do that. So you can do all kinds of things, be very creative. Before I conclude the description of definition process methods that are executed in the definition section, I want to point out a couple of important points, or actually several important points. And these points are all described in the Developer's Manual, Cognition Model Developer Manual, underneath the process methods section in a topic called definition process methods. So I'm not going to take the time to go over all this. I just want to make you aware of the fact that this particular topic exists, and if you're going to write definition process methods, you need to read this topic and pay attention to it. So I'm just going to summarize real quickly. This bullet talks about the fact that some models might not yet be attached, and you have to pay attention to that depending upon the order of the statements in the definition of a unit. It says the configure on unit method hasn't been executed yet, so you have to pay attention to that. It tells you can't execute executable commands from a definition section. That kind of makes sense. It talks about something that we call a temporary unit. It's a unit that Flames uses in the units window to edit units, and sometimes definition process methods will do things that shouldn't be done for a temporary unit, so you need to pay attention to that and consider that in the code that you write. And then it talks about that if you're initiating a command for another unit, or you're doing something that depends on another unit, for example, you're locating information behind another unit, you have to make sure that other unit's already been configured, and it might not yet be configured. So it talks about how to make sure that any unit you depend on is configured. So again, I'm not going to go into detail on that. I'm not going to take up your time here, but if you're going to write definition process methods, you need to come to this topic and read this. And then, of course, look at all of the source code that we provide for many different definition process methods that are executed in the definition section. So that concludes my discussion of the four main ways that process methods can execute. I hope this was helpful, and I hope it gets you excited about all the things that you can do with cognition models and process methods. Thank you for watching, and thank you for using Flames.